Hey guys, so the next section of forces that we're going to be dealing with starts to get into component forces. Right now we've just been dealing with things in one dimension, but the world isn't in one dimension. The world is in three dimensions. Lucky enough for us, normally, regardless of those three dimensions, we can usually observe from one dimension causing it to be two dimensions, right? So if I throw a piece of chalk, I can observe it from a direction where I've just gotten a y and an x, right? I don't really ever have to worry about the z. There's some situations where I'm going to, but normally I don't. But if I want to start working in two dimensions, that really makes things a little more complicated. Because things don't always just work the exact same way. So what we're going to need to start doing is using trigonometry to break things out into those two separate dimensions. So I've decided to give you a crash course in trigonometry, because we're not going to need to use all of trigonometry. We're going to need to use kind of the bare minimum, specifically the Pythagorean theorem and sine, cosine, and tangent, which is actually really simple. The symbols look confusing, but that's just because mathematicians want you to think that no one can do what they can do. They like to use nice confusing symbols, so you'll just leave them alone and let them do their thing. Us physicists, we don't care about that. We're trying to have fun, right? Exactly. So we're going to get into the basic trigonometry points that we're going to need to know. To start off with, you're going to need to know the following things. Sohcahtoa and a squared plus b squared equals c squared. For component forces, just the way we're going to be looking at it now, you're not going to use too much of this, but it will come into play at the beginning of each problem. When we get into vectors, looking at projectile motion and equilibrium of forces, that's when this stuff is going to come into heavy play, okay? So, for now, let's just talk about what this means. What's Sohcahtoa? Well, Sohcahtoa is a nice little way to remember sine, cosine, and tangent and what they mean. See, the sine, cosine, and tangent are just representations of the ratios between the sides of a triangle, of a right triangle. So let's draw one out. So if I've got a right triangle here, and I have this angle, we're gonna mark it with theta. That's the official way that we signify an angle. If we don't know the exact number that defines this angle, we can say theta, and pretty much everyone's gonna know what we mean by that. So theta is gonna be the angle that we're working with. I've drawn this little square to say that this is a right triangle. It is 90 degrees. Right here is an angle of 90 degrees. So theta is something less than 90 degrees. Something, we don't know what. Sine is sine of theta. That's how it would look on your calculator. Actually spelt out, it's S-I-N-E. Of theta is equal to the ratio of the opposite side over the hypotenuse. And what does that mean? Well, the opposite side of this angle is this line right here. So let's mark that with an A. So the side A, whatever that length is the opposite side to this angle, okay? The hypotenuse is always the longest part. That's our C, okay? And a squared plus b squared equals c squared. This can be A, this can be B, or this can be A, or this can be B. But this has to be C. This angle opposite of the 90 degrees must be C. It's always going to be the longest side of a right triangle. So this is the hypotenuse. I'm going to spell this wrong. Hypotenuse. Something like that. And then this is the opposite. I'm probably going to spell opposite wrong too. I'm a physicist, not a language arts teacher. So we can also represent this by saying A over C. So sine of whatever angle is really the ratio of A divided by C. That kind of makes sense, right? Right? So it's not this big, crazy, weird number. It's just a ratio. no matter what size of a triangle we have, if I've got a 30-degree angle right here, my A and C are always going to have the same ratio. Always. No matter where in the universe you are, your A and C will have the same ratio for a 30-degree angle. Okay? Whether A is 5 meters or 1,000 meters. That C is going to be a certain value dependent on that 30 degrees. Okay? The same thing happens with the rest of them. Ca is cosine. So cosine is cosine. That's COS. That's what it's going to look like on your calculator. Theta is equal to adjacent. That's what that A stands for. Adjacent over hypotenuse. The adjacent side is the side next to the angle that is not the hypotenuse. So this is your B. This is your adjacent. Definitely spelled that wrong. Maybe not. I don't know. So another way we can look at that is B over C. It's the same thing. It is the ratio of B over C is equal to the cosine of theta. That's it. That is it. We know that any angle that is not this right angle, this 90-degree angle, has to be less than 90 degrees. And that's always going to have some kind of ratio equal to B and C. So this sine, this cosine, those are called functions. And all they are is a conversion factor from this degree in terms of 360 degrees to a ratio. Okay? Does that make sense? All right. So TOA. TOA is the same thing. It's just a little bit different. It's called tangent. It's going to be on your calculator as tan. Tangent. It's like how I go on many tangents when I'm teaching a lecture. So tan of theta is equal to the opposite over the adjacent. So that's going to be the A over the B. Okay? And it's always got to be that. It's got to be the opposite over the adjacent. It won't work if I take the adjacent over the opposite. It just won't. Okay? It's the way it works. So I'm going to give you guys little handouts that has this information on it so that you don't have to memorize this part. All you're going to have to need to know is how to use these. And we're going to get some practice right here. Okay? So what I want you to remember is these sine, cosine, and tangents, they are just factors that allow you to convert between a ratio of the sides of what they are when we divide them together and the angle in terms of degrees. That's all it is. It's just a conversion factor. That's it. All right? So next, let's take some look at some practice problems putting these to application.